All right, students, I promised I would give a go at making you guys a little video on demonstrating the triangle inequality theorem that you are working hard to understand. Let's take a look. I did a practice round and it was pretty awkward with the tripod and the different parts, but let's do it. So, basically, the triangle inequality theorem states this. It says any side, and you should write this down, any side of any triangle must be, and then there's two qualifications. It must be greater than the difference of the other two sides. Write it down. Or a difference between, but I'm going to write difference of. I guess I should say between. And second qualification, so the side has got to be greater than the difference if you subtracted the other two sides, and it's got to be less than the sum of the other two sides. All right, so make sure you've gotten that written down, and then let's go ahead and see what that would look like. So let's see if we can have a demonstration of what that looks like. So unbelievably frustrating. Oh, no, I'm still here. I thought I had lost my video. Sometimes it turns off in the middle and then I gotta start all over again. But no, we're good, and I didn't even get too riled up. All right. Let's take a look. So I'm just going to demonstrate that with this little pair of straws and a piece of string. So, like I said, it's kind of awkward, but let's give it a whirl. So these are two sides of the triangle, the the pink side and the green side. And what it's showing, or what this theorem states, is that this third side can be many distances. It can be many lengths, but it has to be greater than this amount. This amount is the difference between the larger side and the other side, the other two sides. And you can see that if it is not greater than this amount, then it's just a straight line. So it has to be larger than that difference in order to make a triangle. Now, it's a longer distance and it can make a triangle. Here, it is the difference between the two, and it's just a straight line. But now that third side is longer, it's greater than the difference, and it can make a triangle, and it can make a triangle, and it can make a triangle. Sorry, I know it's so awkward. And it can still make a triangle, and it can keep making a triangle with that distance getting greater and greater and greater. There, it's a nice triangle, until the point where that third side is equal to the sum of the other two sides. And that third side cannot be that long, because once it's that long, again, it's just a straight line. So to make a shape, it's got to be less than the sum if you added these two together. So it has to be less distance than that, but it's got to be greater than if you subtracted the other two sides, because that's the difference. And if that third side was just the difference, it's not long enough to make a triangle. It's just a straight line. And if that side is greater than the sum of both sides, it just makes a straight line. Because if you add the two sides together, and that is the distance of your third side, that's just a straight line. So it has to be less than the sum, but greater than the difference. So, for example, in the case of these little straws, this one's 2 inches, and that one's 3 inches. So if this third side was 5 inches, which it is, it's 5 inches, then that just makes a straight line. But if this third side was 4 inches, I'll just hold it off at 4 inches, then, oh my gosh, it is difficult. Well, any amount less than the 5 inches will make a nice triangle. If it was only the difference between these two is, I actually had a little piece of straw for that too. Oh, here it is 1 inch. See that? Oh, it's actually, this one's not cut quite perfect. Let me cut it a little bit better. Is 1 inch, and that is too short. So it has to be longer than this one, but not as long as this one. And students, so it can be shorter as long as it's longer than that. And once you understand the basic principles, students, you just can use the numerical quantities to figure this out. And that's what they're asking you to do in your practice activities, is they're giving you a triangle. And what's weird about it is that maybe the triangle doesn't look like, you look at it and you would guess that it's a certain length, but they're giving you hypothetical numbers. So they might say side one is, say, 10 units, whatever it is, and side 2 is, maybe we'll say it's 2 units, and side 3 is, let's say side 3 is 6 units. They wouldn't say it like that because it's confusing with all those numbers. And then they say, is this a triangle that is possible? And you have to be able to say, well, for this side to work, it has to be greater than the difference between these two. Well, the difference between side 1, which is 10, and side 3, which is 6, the difference is 4. And this side has to be more than the difference, and it's not. So this is an impossible triangle. If I tried to draw that triangle, it would not work out because it would just be like a weird straight line. It's not possible. So that's what they're asking you to do, is to assess these triangles. So remember, we'll just call them side A, B, and C. So side A has to be greater than B minus C, or C minus B, whichever is bigger, and it has to be less than B plus C, or C plus B. Okay? Does that make sense? I hope it helps, and I'll see you guys soon. All right, bueno, bye.